Good afternoon, geometry students. We are moving on to lesson 5.4 in our chapter on triangles. I kind of like this chapter because we get to do proofs, and also because I think that triangles are the best way in which to learn how to do proofs. They're very visual, and so it makes it a little bit easier to talk about. We are going to learn just a few very specific theorems about isosceles and equilateral triangles today that will help us in proofs when we're working with isosceles and equilateral triangles. So I guess a good way to start off our notes, by the way, please do put at the top of your paper 5.4 isosceles and equilateral triangles. And isosceles is I-S-O-S-C-E-L-E-S. So it's a little hard to spell. We have discussed this before earlier in the quarter, but just a little mini review. When we're talking about an isosceles triangle, do you remember what that means? An isosceles triangle is when you have a triangle where two of the sides are congruent, at least two. And this angle here would be called the vertex, and the two angles across from the congruent sides would be called base angles. So that's a base angle, and that's a base angle. So we're going to learn a couple theorems. The first is the base angle theorem. So base angle theorem. And it's okay to abbreviate theorem just THM. The base angle theorem tells us if two sides of a triangle are congruent, then the angles opposite them are. So let's write that down. If two sides of a triangle are congruent, then the angles opposite them are. So what that means is if you have an isosceles triangle and these two legs are congruent, then the two base angles are also going to be congruent. Now the cool thing is that the converse is also true. So let's write converse of base angle theorem. Now I'm wondering if you can figure out what that would be in your notes. You know what converse means, and we've talked about converses several different times. Look at what the theorem is and you tell me what would be the converse to the base angle theorem. Okay, let's give it a try. If two angles of a triangle are congruent, then the sides opposite them are. So you can read the biconditional theorem this way from left to right, but reading it backwards, the converse is also true. So then there are a couple corollaries about equilateral triangles. Equilateral triangles are where you have a triangle with how many sides that are congruent? 3. So we've got 3 sides of a triangle are congruent. The conditional statement is if a triangle is equilateral, then it is equiangular. What does that mean? It means that if all 3 sides of a triangle are congruent, then all 3 angles are. What would each of the angles have to be? They'd all have to be 60 degrees. And then you can also do the converse. If a triangle is equiangular, so if a triangle is equiangular, then it is equilateral. And I apologize that you guys are having to write down all this stuff. Normally I would have most of this in handout notes for you, but obviously it's not practical for most people to print, and it's also not practical for your parents to be coming to the school and picking up papers. So we're just going to do an abbreviated version of the notes. Let me go ahead and give you, let's do one word problem and then one regular example and one proof. And I think that'll be kind of a good representation of the types of problems you might encounter using these theorems and corollaries. And then during our Zoom session, we'll do a lot more examples. So kind of let's do a word problem first. Example number 1. It says triangle, you don't have to write this down, we'll just draw the picture. So triangle ABC is an isosceles triangle. So let's draw this triangle here. A, B, C. With BC congruent to BA. So we can mark this side and that side. If the measure of angle B is 40 degrees, and the measure of angle C is 5x, then find the value of x and the measure of angle A and C. So does anyone have an idea of how we would start here? Because we need to be able to use the information we already knew about triangles and combine it with the information we just learned today to set up an equation to solve this. Who can tell me what this angle would be right here? Notice that we've got an isosceles triangle, so because of that, the angles opposite the legs must also be congruent. So if this angle is 5x, then that angle is going to be 5x as well. So that's the key to solving this one. Then we know from our previous lessons, the triangle angle sum theorem, that all 3 angles have to add up to 180. So I know I can take 5x plus 5x plus 40 and set it equal to 180. I'm going to combine like terms to get 10x plus 40 on one side and 80 on the other. I'm going to use my opposite operations to subtract 40 from each side. And then I'm going to divide both sides by 10 and get x equals 14. Now notice we're not done, because it said find the value of x and the measures of angle A and C. So we do need to plug 14 back in here. When you take 5 times 14, you get 70 degrees. So the angles in the triangle would be 70, 70, and 40. So that would be an example of a word problem. Okay, let's do example number 2. Just a straightforward problem that we have diagrammed for us. We've got a triangle here, and these 2 sides are marked as being congruent. Let's call it triangle X, Y, Z. And we also have some information here that this angle is 60 degrees. Now this is a little bit of a trick question, but I'm wondering if you can tell me what the other 2 angles are. We know that because this is an isosceles triangle, these 2 angles have to be the same. We also know that all 3 angles add up to 180, and this takes up 60 of that 180. So there's 120 left, but because these have to be congruent, what's the only way I can have 2 angles that measure the same thing that add up to 120? These would have to be 60. So now we're going to use the other corollary we talked about. Since all 3 angles are the same, we can now mark another side here as being congruent, because if the triangle is equiangular, it also has to be equilateral. So we know that this is actually, even though they didn't tell us that, an equilateral triangle. Now it says solve for x. The sides as marked here are 3x plus 8 for xz, and then for zy, 4x minus 4. The deal here is you don't actually need to know this other side because all 3 sides are congruent. So we would just set 3x plus 8 equal to 4x minus 4. Then we subtract 3x from each side, and then add 4, and we get x equals 12. And I think in that particular case, we just had to solve for the variable, so we're done. Now, I do want to do one proof with you guys because this is our chapter on proofs, and I would like it to be a proof that uses the material that we just talked about in the notes. So I'll give you the information for the proof, and we're going to do that as example number 3. And then I'll draw a picture here for you. And again, please do pause as you need to, to write down whatever information you need to copy the picture or to make sure your equation's correct. I'm trying not to take too long because I don't want the length of these videos to be too long. So we've got our vertices marked as A, B, C, D, and E. And then that's all the information on the given picture, but we do have a fair amount of information given right next to the word given. So it says AE is congruent to DE, and angle EBC is congruent to angle ECB. That's all the given. What I like to do is I like to mark that up on the picture. It says that AE is congruent to DE. So that's going to be this length here. And also that angle EBC, so if I go from E to B to C, that would be right there, is congruent to ECB, this angle right here. So you can kind of see this isosceles triangle hidden in here. All right, so let's think about maybe how that might help us. Okay, and now what we're supposed to prove is that triangle AEB is congruent to triangle DEC. All right, remember our first step is always to draw the letter T. Our second step is to write statements on the left and then reasons on the right. Who can tell me what we do next after we write statements and reasons? The next thing we would want to do is write down whatever we've been given as our first statement. So I'm going to write here AE is congruent to DE and angle EBC is congruent to angle ECB. I'm just literally copying down the information I was given. And of course, my first reason is always the word given. Now, we need to know a little bit more about what's going on here. We are trying to prove that triangle AEB, that's this green triangle right here, is congruent to triangle DEC, which is this green triangle right here. So we don't actually have to prove this in any particular order, but can you either see where there is a pair of congruent angles or where there is another pair of congruent sides? It doesn't matter which one we say next in our proof. I think what I chose to do when I wrote this out is I did the sides next, so I put, these two angles right here next. So I'm going to write that down. See if you can figure out the reason. I'll write the statement. Statement 2 is angle AEB is congruent to angle DEC. Why is it that those two angles are congruent? Now, if you're really wanting to get better at proofs, you should have your word bank for Chapter 5 proofs out and look under the header that says ways to prove two angles are congruent. That might help you. The hint is it starts with the letter V. So hopefully you said vertical angles are congruent. If you did, good job. Okay, now, can anyone guess how it is that I would say that BE is congruent to CE? Why is it that I can say that segment BE is congruent to segment CE? This has to do with the lesson we just learned. It's the converse of the base angles theorem. Because with this orange triangle here, we know that these two angles are congruent, so it must be that the sides opposite the angles are also congruent. Now let's look at the green triangles. Why is it that we might be able to say that those two green triangles are congruent. Notice that we have two sides marked up and an angle included between those two sides. So we have two corresponding sides that are congruent as well as their included angles. So think about that for a moment. Look at the picture, see how it's marked up. Our last statement is going to be that triangle AEB is congruent to triangle DEC. This is what we were trying to prove. I hope that you came up with the reason. The reason is side, angle, side. So thank you so much for listening to the notes. I'm looking forward to seeing you in Zoom.